Welcome to CO556 Network Systems. This is week 5 and this is chapter 6 of the Cisco syllabus. This week we are looking at Ether channel. So our objectives this week are to obviously discuss Ether channel. We're going to look at troubleshooting Ether channel on switch links. We're going to talk about Ether channel operation and describe Ether channel technology. We're going to look at how to configure Ether channel and how to verify and troubleshoot Ether channel. So Ether channel operation, link aggregation. So there are two scenarios in which more bandwidth or redundancy between devices is needed than what can be provided by a single link. Multiple links could be connected between devices to increase the bandwidth. However, spanning tree protocol, which is enabled on layer 2 devices like Cisco switches by default, will block redundant links to prevent switching loops. A link aggregation technology is then needed that allows redundant links between devices that will not be blocked by STP, spanning tree protocol. That technology is known as Ether channel. Ether channel is a link aggregation technology that groups multiple physical Ethernet links together into one single logical link. It is used to provide fault tolerance, load sharing, increased bandwidth, and redundancy between switches, routers, and servers. Ether channel technology makes it possible to combine the number of physical links between the switches to increase the overall speed of switch-to-switch communication. Ether channel technology was originally developed by Cisco as a LAN switch-to-switch technique of grouping several fast Ethernet or gigabit Ethernet ports into one logical channel. When an Ether channel is configured, the resulting virtual interface is called a port channel. The physical interfaces are bundled together into a port channel interface, as shown in this figure. Here we can see that there's one single switch at the bottom, and there are two multi-layer switches. Both have Ether channels going to them, made up of two single port channels taken from the single switch at the bottom. So those two ports are being combined into a single Ether channel, up to the multi-layer switch on either side. Some advantages of Ether channel. Ether channel technology has many advantages, including the following. Most configuration tasks can be done on the Ether channel interface instead of on each individual port, ensuring configuration consistency throughout the links. Ether channel relies on existing switch ports. There is no need to upgrade the link to a faster and more expensive connection to have more bandwidth. Load balancing takes place between links that are part of the same Ether channel. Ether channel creates an aggregation that is seen as one logical link. When several Ether channel bundles exist between two switches, spanning tree protocol may block one of the bundles to prevent switching loops. When spanning tree protocol blocks one of the redundant links, it blocks the entire Ether channel. This blocks all the ports belonging to that Ether channel link. Where there is only one Ether channel link, all physical links in the Ether channel are active because spanning tree protocol sees only one logical link. Ether channel provides redundancy because the overall link is seen as one logical connection. Additionally, the loss of one physical link within the channel does not create a change in the topology. Some implementation restrictions. Ether channel has certain implementation restrictions, including the following. Interface types cannot be mixed. For example, fast Ethernet and gigabit Ethernet cannot be mixed within a single Ether channel. Currently, each Ether channel can consist of up to 8 compatibly configured Ethernet ports. Ether channel provides full duplex bandwidth up to 800 megabits per second, fast Ether channel, or 8 gigabits per second, gigabit Ether channel, between one switch and another switch or host. The Cisco Catalyst 2960 Layer 2 switch currently supports up to 6 Ether channels. The individual Ether channel group member port configuration must be consistent on both devices. If the physical ports on one side are configured as trunks, the physical ports on the other side must also be configured as trunks within the same native VLAN. Additionally, all ports on each Ether channel link must be configured as Layer 2 ports. Each Ether channel has a logical port channel interface. A configuration applied to the port channel interface affects all physical interfaces that are assigned to that interface. Auto-negotiation protocols. Ether channels can be formed through negotiation using one or two protocols. Port Aggregation Protocol, PAGP, or Link Aggregation Control Protocol, LACP. These protocols allow ports with similar characteristics to form a channel through dynamic negotiation with adjoining switches. Note, it is also possible to configure a static or unconditional Ether channel without PAGP or LACP being involved. PAGP operation. PAGP is a Cisco proprietary protocol that aids in the automatic creation of Ether channel links. When an Ether channel link is configured using PAGP, PAGP packets are sent between Ether channel capable ports to negotiate the forming of a channel. When PAGP identifies matched Ethernet links, it groups the links into an Ether channel. The Ether channel is then added to the spanning tree as a single port. When enabled, PAGP also manages the Ether channel. PAGP packets are sent every 30 seconds. PAGP checks for configuration consistency and manages link additions and failures between two switches. It ensures that when an Ether channel is created, all ports have the same type of configuration. Note, in Ether channel, it is mandatory that all ports have the same speed, duplex setting, and VLAN information. Any port modification after the creation of the channel also changes all other port channels. PAGP helps create the Ether channel link by detecting the configuration of each side and ensuring that links are compatible so that the Ether channel link can be enabled when needed. The modes for PAGP are as follows. On. This mode forces the interface to channel without PAGP. Interfaces configured in the on mode do not exchange PAGP packets. PAGP desirable. This PAGP mode places an interface in an active negotiating state in which the interface initiates negotiations with other interfaces by sending PAGP packets. PAGP Auto. The PAGP mode places an interface in a passive negotiating state in which the interface responds to the PAGP packets that it receives but does not initiate PAGP negotiation. The mode must be compatible on each side. If one side is configured to be in auto mode, it is placed in a passive state, waiting for the other side to initiate the Ether channel negotiation. If the other side is also set to auto, the negotiation never starts and the Ether channel does not form. If all modes are disabled by using the no command, or if no mode is configured, then the Ether channel is disabled. The on mode manually places the interface in an Ether channel without any negotiation. It works only if the other side is also set to on. If the other side is set to negotiate parameters through PAGP, no Ether channel forms, because the side that is set to on mode does not negotiate. No negotiation between the two switches means there is no checking to make sure that all the links in the Ether channel are terminating on the other side, or that there is a PAGP compatibility on the other switch. We can see in this table the various different combinations of PAGP modes between two switches S1 and S2. We can see that of all the different combinations, on one side and desirable or auto on the other will not produce a channel establishment. Similarly, auto on both sides in the passive mode also doesn't provide channel establishment. Other combinations will though. LACP operation. LACP is part of the IEEE specification 802.13 AD that allows several physical ports to be bundled to form a single logical channel. LACP allows a switch to negotiate an automatic bundle by sending LACP packets to the other switch. It performs a function similar to PAGP with Cisco Ether channel. Because LACP is an IEEE standard, it can be used to facilitate Ether channels in multi-vendor environments. On Cisco devices, both protocols are supported. LACP provides the same negotiation benefits as PAGP. PAGP, or LACP, helps create the Ether channel link by detecting the configuration of each side and making sure that they are compatible so that the Ether channel link can be enabled when needed. The modes for LACP are as follows. On. This mode forces the interface to channel without LACP. Interfaces configured in the on mode do not exchange LACP protocols, packets. LACP active. This LACP mode places a port in an active negotiating state. In this state, the port initiates negotiations with other ports by sending LACP packets. LACP passive. This LACP mode places a port in a passive negotiating state. In this state, the port responds to the LACP packets that it receives but does not initiate LACP packet negotiation. In this table, we can see the various different combinations that we can have between two switches using LACP. You will notice that it's exactly the same as the PAGP in terms of operation, in terms of which combinations don't provide channel establishment. So on one side, active or passive on the other, will not produce a channel establishment, nor will passive-passive. All other forms will, just like PAGP, just that we're using a different keyword really. So active in LACP rather than desirable in PAGP, and passive rather than auto in PAGP. Configure Ether channel. Configuration guidelines. The following guidelines and restrictions are useful for configuring Ether channel. Ether channel support. All Ethernet interfaces must support Ether channel with no requirement that interfaces be physically contiguous. Speed and duplex. Configure all interfaces in an Ether channel to operate at the same speed and in the same duplex mode. VLAN match. All interfaces in the Ether channel bundle must be assigned to the same VLAN or be configured as a trunk. Range of VLANs. An Ether channel supports the same allowed range of VLANs on all interfaces in the trunking Ether channel. If the allowed range of VLANs is not the same, the interfaces do not form an Ether channel, even when they are set to auto or desirable mode. The figure below shows a configuration that would allow an Ether channel to form between S1 and S2. If these settings must be changed, configure them in port channel interface configuration mode. Any configuration that is applied to the port channel interface also affects individual interfaces. However, configurations that are applied to the individual interfaces do not affect the port channel interface. Therefore, making configuration changes to an interface that is part of the Ether channel link may cause interface compatibility issues. The port channel can be configured in access mode, trunk mode, which is the most common, or on a routed port. LACP configuration example. Configuring Ether channel with LACP requires the following 3 steps. Step 1. Specify the interfaces that compose the Ether channel group using the interface range followed by the interface number global configuration mode command. The range keyword allows you to select several interfaces and configure them all together. Step 2. Create the port channel interface with the channel group and then the identifier number mode active command in interface range configuration mode. The identifier specifies a channel group number. The mode active keywords identify this as a LACP Ether channel configuration. In step 3, to change layer 2 settings on the port channel interface, enter port channel interface configuration mode using the interface followed by the port channel command followed by the interface identifier that you set when you created the channel group. In the example, S1 is configured with the LACP Ether channel. The port channel is configured as a trunk interface with the allowed VLAN specified. As you can see, this example is worked through in the commands below. So we have on S1 global configuration mode, interface range fast Ethernet 01 to 2. In the configuration for the interface range, we are creating our channel group. So channel group 1 mode active using LACP. We then exit back to the global configuration, or go to the interface range. We then move into interface port channel 1, which we put into switch port mode trunk, switch port trunk allow, and we allow VLANs 1, 2, and 20 to go over it. There's a little packet tracer exercise on configuring Ether channel, well worth doing. Configure the basic switch settings, configure an Ether channel with Cisco PAG-P, configure an 802.3 AD Ether channel using LACP, and configure redundant Ether channel links. Verify and troubleshoot Ether channel. Verify Ether channel. As always, when you configure devices in your network, you must verify your configuration. If there are problems, you will need to be able to troubleshoot and fix them. There are a number of commands to verify an Ether channel configuration. The Show Interfaces Port Channel command displays the general status of the port channel interface. The Show Ether Channel Summary command displays one line of information per port channel. The Show Ether Channel Port Channel command displays information about a specific port channel interface. The Show Interfaces Ether Channel command can provide information about the role of the physical member interface of the Ether channel. Common issues with Ether channel configurations. All interfaces within an Ether channel must have the same configuration of speed and duplex mode, native and allowed VLANs on trunks, and access VLANs on access ports. Ensuring these configurations will significantly reduce network problems related to Ether channel. Common Ether channel issues include the following. Assigned ports in Ether channel are not part of the same VLAN or not configured as trunks. Ports with different native VLANs cannot form an Ether channel. Trunking was configured on some of the ports that make up an Ether channel, but not all of them. It is not recommended that you configure trunking mode on individual ports that make up the Ether channel. When configuring a trunk on an Ether channel, verify the trunking mode on the Ether channel itself. If the allowed range of VLANs is not the same, the ports do not form an Ether channel, even when PAG-P is set to auto or desirable mode. The dynamic negotiation options of PAG-P and LACP are not compatibly configured on both ends of the Ether channel. Troubleshoot Ether channel example. In the figure, interfaces Fast Ethernet 1 and Fast Ethernet 2 on switches S1 and S2 are connected with an Ether channel. However, the Ether channel is not operational. Step 1. View the Ether channel summary information. The output of the Show Ether channel summary command indicates that the Ether channel is down. Step 2. View port channel configuration. In the show run with the filter of begin interface port channel, output more detailed output indicates that there are intercompatibility PAG-P mode configured on S1 and S2. Step 3. Correct the misconfiguration. To correct this issue, PAG-P mode on the Ether channel is changed to desirable. We should note that Ether channel and spanning tree protocol must interoperate. For this reason, the order in which Ether channel related commands are entered is important, which is why you see the interface port channel 1 removed and then re-added with the channel group command as opposed to directly changed. If one tries to change the configuration directly, spanning tree protocol errors cause the associated ports to go into blocking or error disabled state. Step 4. Verify Ether channel is operational. The Ether channel is now active as verified by the output of the Show Ether channel summary command. We have a little packet tracer exercise to troubleshoot Ether channel. So in the packet tracer, you get to examine the physical layer and correct switch port mode issues, identifying correct port channel assignment issues, and identifying correct port channel assignment issues. We also have a little packet tracer exercise on implementing Ether channel. So in the packet tracer exercise, you get to build the network and configure Ether channel. So what did we learn in this presentation? To increase bandwidth or redundancy, multiple links could be connected between devices. However, spanning tree protocol will block redundant links to prevent switching loops. Ether channel is a link aggregation technology that allows redundant links between devices that will not be blocked by spanning tree protocol. Ether channel groups multiple physical Ethernet links together into one single logical link. It provides fault tolerance, load sharing, increased bandwidth, and redundancy between switches, routers, and servers. When an Ether channel is configured, the resulting virtual interface is called a port channel. Ether channels can be formed through negotiation using one or two protocols, PAGP or LACP. These protocols will allow ports with similar characteristics to form a channel through dynamic negotiation with adjoining switches. When an Ether channel link is configured using Cisco proprietary PAGP, PAGP packets are sent between Ether channel capable ports to negotiate the forming of a channel. Modes for PAGP are on, PAGP desirable, and PAGP auto. LACP performs a similar function to PAGP and Cisco Ether channel. Because LACP is an IEEE standard, it can be used to facilitate Ether channels in multi-vendor environments. Modes for LACP are on, LACP active, and LACP passive. The following guidelines and restrictions are useful for configuring Ether channel. All Ethernet interfaces on all modules must support Ether channel with no requirement that interfaces be physically contiguous or on the same module. Configure all interfaces in an Ether channel to operate at the same speed and in the same duplex mode. All interfaces in the Ether channel bundle must be assigned to the same VLAN or be configured as a trunk. An Ether channel supports the same allowed range of VLANs on all interfaces in a trunking Ether channel. Configuring Ether channel with LACP requires 3 steps. Step 1. Specify the interfaces that compose the Ether channel group using the Ether interface range interface global configuration mode command. Step 2. Create the port channel interface with the channel group identifier mode active command in an interface range configuration mode. Step 3. To change layer 2 settings on a port channel interface, enter port channel interface configuration mode using the interface port channel command followed by the interface identifier. There are a number of commands to verify the Ether channel configuration, including show interfaces port channel, show Ethernet Ether channel summary, show Ether channel port channel, and show interfaces Ether channel. Common Ether channel issues include the following. Assigned ports in the Ether channel are not part of the same VLAN or not configured as trunks. Ports with different native VLANs cannot form an Ether channel. Trunking was configured on some of the ports that make up the Ether channel, but not all of them. If the allowed range of VLANs is not the same, the ports do not form an Ether channel, even when PAGP is set to auto or in desirable mode. The dynamic negotiation options of PAGP and LACP are not compatibly configured on both ends of the Ether channel.